Okay, here we have one that says, how long does it take for an investment to double in value if it is invested at 10% per annum, compounded monthly, and then compounded continuously? This is actually going to be two problems that we're going to do in one. So, first of all, we're going to talk about the compounded monthly situation. So since that's compounding monthly, that means we're going to be using our regular old compounded interest formula, which is A equals P times 1 plus R over N to the NT power. In order to use this formula, we need to identify each one of our variables. So we've got A, P, R, N, and T. Okay, so how long does it take for an investment to double in value if it's invested at 10%? So that's our interest rate, 10%. Compounded monthly. That tells us that this is happening 12 times a year. Now, our original problem here, how long does it take? That tells us that our variable here is going to be time. That's what we're going to end up solving for. So I'm going to leave that as a t. But they did not give us an A or a P, a principal amount or an ending amount. Specifically, I mean, they didn't say, you're starting out with $1,000. They just said that they want our investment to double. So however much we start with, let's start off with a principal of X, then we would end up with an amount after time of twice that much, or 2 times X. Now that is perfectly legal to do, and whenever we get started here, you'll see what happens. Alright, so if I plug this into my formula, then that means I would have 2x equals, instead of p, we're putting in an x, times 1 plus, the interest rate is 0.10, divided by n, which is 12, raised to the 12t power. Remember, t is what we're going to be solving for. Alright, so to get started here, you notice how we have 2 times x over here, and we have x times something over here? Let's divide both sides by x to get rid of it. When we do that, the x's cancel out, and now we have 2 equals 1 plus 0.10 divided by 12 to the 12t power. It doesn't really matter what you start with. You're going to end up with twice that amount. I mean, we could have literally put in a number here. We could have put in 1,000 and 2,000. And then when we divide by 1,000, we're going to still end up with the exact same equation. Okay, let's go ahead and simplify these parentheses now. So we'll have 2 equals, you can just plug this in on your calculator, and you should get 1 point and then a huge decimal. I got 1.008, and then 3's that went on as long as the calculator would allow. So to the 12t power. Now this is important. At this point, you probably want to keep this in your calculator, not do anything else for the time being, because we're going to use that number in just a second. Okay, so now, since I'm solving for a variable that's up in an exponent, we're going to have to take the natural log of both sides. So I'm going to do that. Now that leaves us with the natural log of 2 equals, by doing that, we can now bring that exponent right down in front of that natural log. So this would be 12t times the natural log of that 1.008, and then all those 3's repeating. Now to solve for t, we just divide both sides. So the natural log of 2 divided by 12 natural log of 1.0083 repeating. Now it's trying to put this into our calculator that's going to be very delicate, so we'll do this in the next part of the video.